Hello everyone, it's April 25th. Alright, so we're doing a little bit earlier. Hopefully we will get a better result. Alright, count subarray with fixed bounds. A given integer. Alright, I'm back. Alright, let's do this. Alright, integer array nums and two integers min and max. A fixed bound subarray of nums is a subarray that satisfies the following conditions. Minimum value is equal to min k. Max value is equal to max k. Return the number of fixed bound subarrays. Fixed bounds are so a subarray with min value and max value set. One, 3, 5, 2, 7, 5. Min is 1, so we want a subarray with a min value and a max value. So if I start from here, min is 1, so I can keep track. Min is 1, max is 1, min is 1, max is 3, min is 1, max is 5, right? So that's 1, and oh yeah, I can keep going until I fail, but then I have to get back, move forward, and then move forward. Yeah, it's the same problem that we have to go back and forth. So we find the smallest. What I want to know is what's the next one that's bigger than me? That sounds like a monotonic array. Because monotonic will go 1, 3, 5, 2 will come in and destroy all of them. Right? Which is fine. Right? Which is fine because So if we go monotonic increasing, right? I have something, and once the min comes in, it will pop everybody else if we have something that's bigger, right? It doesn't matter. It will come in, pop everything out. So this is our starting point. Because everybody to the left will be bigger than it. Right? Everybody to the big will be bigger than it. Yes. Like something small comes in because we're monotonic increasing. Something small comes in, it will pop everybody's bigger and it will stop by something that's even smaller than it. So everybody in between is fair game. Right? And we go. Then we have the current large comes in. Right, which is fine. Right, and we keep going. So now there are two scenarios. One is we have the same small comes in. And it will pop everything. Except the one. And let's don't pop it. So when that happens, we need to keep track the current largest in this range. Right? So if in this range, the max k is not found, that's basically like nothing. You can't really do anything about it. Right? If the max k is found in this range, then if max k is in this range, it's like when max comes in, like if I have 1, right, and then we have something small, right, and then this is like, let's say it's 0, but I cannot get 0, but it's fine. Let's just get something small. So everybody in this is fair game, right? And then I got 5, which is the max. Yes, so this condition is we don't have any of the bigger ones in between. So we got a 5. Everybody inside this. So if I pop, that's not gonna work. So let's just suppose everybody is small, is in between. That's like good case, right? It's good case. Happy path. So we got this. Then when we got this, we basically have from here to here, because everybody's small, right? And then we all add everybody here. So if you have however many, that's how many, we're ending it here. And now we come somebody, if it's bigger, then we basically reset, right? Because we cannot do this. If it's bigger, then we reset. If it's smaller, it depends, right? If it's smaller, then we'll pop, right? We'll pop. But the current biggest is still valid, right? So we'll pop. It could be, so if it's like, it's the smallest, so I don't, if it's a small, like if it's like a 2, right? So I pop this and I'm putting here, and then it's everything as well, right? Yeah, we can record its position. We know what its position is. Right? We know its position. So when a small comes in, I find out if every time if a small come in, would you say ending at this, right? Ending at this, how many? Ending at this, how many? So ending at 5, how many? It's the same. Ending at this, how many? Ending at this, how many? Ending at this, how many? and then I come a bigger one. So ending at this is nothing, right? So we basically reset, right? Okay, so I think these are the happy case. So now the unhappy case is the unhappy case is if I got a 1, if I got a min. If I got a min, I can do the happy case, right? But then the problem is I need to restart. Huh. I don't know. Maybe I should pull them out, min and max. Right? So in the first case, basically I have 1 something, 5 something, something, and 5. This is what we have. Yeah, we have a bunch of 1s or a bunch of 5s. Then what we want to know is within this range, do we have anything bigger? And if we find something smaller, that's also no good. But I think the difficult part is if we find something that's the same. So you have to like keep track of 2, right? Maybe we can think about it differently. So this is a fixed bound subarray, right? Which means in the subarray, the min and max is specified. Which means all the arrays that contains the value bigger or smaller than min k and max k are not allowed. So if that is the case, in this example, right? If that is the case, then in this example, we know the total number of subarrays. The total number of subarrays is 1, 2, 3, 4, 5, 6. So it's gonna be 6 times 7 divided by 2, which is 21, right? That's the total number. And we need to find all the subarrays that includes this 7, all the subarray that includes 7. So all the subarray that includes 7 are Now, it could be all the subarrays that include 7. We have 10. Oh, also like all the subarrays that do not include our target. All the subarrays that do not include our target. Okay. All the subarray that do not include our both of our target. That doesn't make any sense. Yeah, that's actually not that easy to do because there'll be overlap. There will be double counting stuff. So I have min, max, min. So I say max, min, max, right? It doesn't matter. So that's the min max. And for each min, we must pair with a max. So I'll find a max. So I say include this and this, include this and this, include this and this, right? So that's all the possible pairings. So I must include these and these alone. And then what we need to find is the min value in this range, the max value in this range, right? How do you find that? You can use a segment tree for this, but I doubt this is segment tree. And if it is, I am not doing it. Yeah, segment tree will be able to do, but even with segment tree, this is going to be causing a lot of time because you have to pair with all of them, right? And each pairing, yeah, I don't think so. What's the trick here? Thinking back to two-pointer, right? As we two-pointer, we go, we find the first. So if we go, fail, right? And then we basically move the starting point to behind the fail because we cannot use the fail at all. And then we go, fail. Okay, we move forward. But if we go, then we hit a success, right? And boom, we hit a success. Now, once we hit a success, we can also know where the min is, right? So that is everything. And then you keep moving on. Yeah, the difficult part is like if a mean comes again. Right, if a mean comes again. It will fit at the beginning and I'll have a new one. And the min comes again. Right, and min come and max come, and then the min come. Then you have to do multiple. Min, okay, it doesn't matter me and myself. We have one pointer. We have one is here, and then we look for all of these. I kind of want to get back to this idea again, right? So if I do this, I know it's index, right? I know it's, but well, how do you know that this is good? How do you know this is good, right? This range is good. How do you know? Well, the answer is I don't, right? I don't know it's good, but I keep moving forward like one path, right? So I move forward, I know that this range is good. And yeah, but then we have another one coming in, right? How do you handle that? Yeah, each time you have a small, you have a big come in, that's a reset. That's fine. That's easy to do. Reset is easy to do. What is hard to do is you got repeats, right? You got repeats coming in, and I feel the state is a little bit difficult to deal with. Yeah, like if you have, you know, A, right? That's min, max, max, max. So basically, for this case, when you have this A, you do whatever this is a range. And this one, if it's within range, you do this. When you do this, you do this. Now this A comes in. Now I can still do this, right? I can still do this, which is, we can compute that. And we also need to, actually this one is fine. This actually is fine. It's not different from the other ones because I need I anyway. I right, so each time a min or a max comes in, we can look to the left, see what are the previous maxes. If it's a min, right? If it's a min that comes in, I'll look to the left for all the previous maxes that has happened before. and each one can form, right? Each one can form something. Because we go through all this, if everybody in between is good, right? It's the understanding everybody in between is good, right? Everyone in between is good, because if it's bad, we will have a reset already. So in this range, everything is good. If everything is good, then the problem becomes, I want to find all of it that ending in me, right? All of them that ends in me. And the next one is actually can do exactly the same, it will be the same count. So all of them ending in the current. So the current can be a min, it can be a max. So I need to find everything that ending at this one. How do I do that? Well, I look to the left to find my complementary, right? So I find a complementary. I know its total. Okay, I think I have an idea. So again, like I said, as we go through this list, right? We'll have a low and we'll have a high, and then if low hit, like if high hits a, and then we also we'll add them together, add the indices together. So we get low is pointing to something in range. If you know, we start low will be this, will be at this position. So whenever high hits someone that's outside the range, we'll move low forward as well, and a high will go. So low are pointing to the first in range number, right? So low is the first in range. First in range value, that's low. And a high will go, and high will hit a min, or high will hit a max, right? So if I high hit a min, then I want to know all the subarray that's ending at min. So we need to look at max previously, right? And I'll keep a running sum, right? So we have a running sum of max count, not max count, running sum of subarrays ending at max, running total, right? Okay, let me rewrite this. So we need a running total of subarray that ends at each max, right? So when we hit a max, I can use that minus low, so I know the current count. And then I move on for the next max, and I'll do that minus that. That is the total count, right? So when we hit a min, I look at this running sum total, because for each max, I can form that many more, right? I can form that many subarray that satisfies. But if the sum is 0, then you just get 0, like we haven't hit a max yet. So yeah, that's what the min is. And when I hit a max, I do the same thing with the min. And every other number in between will copy the sum of min and max, the running total. Is that right? So we hit a min, right? And then we basically say every max, the running sum of max, because they can all be ending at here, right? So that's all good, right? And We move on to the next one. This will basically use exactly the same as the previous. Right, exactly. So we ending at here. So we have the total, everything, right? We just add that one again, add this one again, because if I have something that's in range, right? So we have a number that's in range. I want to know how many subarrays ending at this one, this in range, satisfies. So we need to look into the previous. How many, right, previous that satisfies. So we look at the previous one, it's also in range. So we say how many ending at this one satisfies. Everyone that ends at this one satisfies, everyone ending at me also satisfies. So we just basically doubles it, right? We doubles it. Yeah, everything ending at me, that's working, and everything ending at the next one will also work. So when I hit a something, when I hit a when I hit a min, so everything previous, so I do that, but then I can expand because everything ending at now the min is a new one, so I can go find a new ending at min. Hold on. Make sure that I'm not double counting. So everything ending at min, let's say min is the first one that shows up, and I have max in the previous, right? Let's say we have a couple of max previously. So I know the count of this, I know the count of this. So ending at min that satisfies is we add this thing, we add this thing. Okay? That's everything ending at min. Perfect. Now the next one comes in. The next one is also in range. So everything that previously works, this one will also work. So I just double the previous one. Next, so everything that previous work will work here as well. And then there will be no new ones because you have to include, right, the min and the max. Okay, now the interesting comes. What if I have a min comes again? Well, if this min comes again, I can treat that as just a regular in range, right? If it's a regular in range, everything basically, the previous one works, this one will also work. But in addition, I am unlocking new possibilities. But are you unlocking new possibilities though? Because the previous, let's say I have this range, right? And everybody will include this, everybody include this. So if it's a min, right, if it's a min, then it doesn't really change because I still need the previous maxes, right? So if I have a min and previous is a min, then that's the exact same. It doesn't really change anything. This one still requires this, but I can redo it. I essentially can redo it and ignore the previous. I can just say, yeah, I'll have, everything here. I'll have everything there, which I think will be the same. Yes, it will be the same because ending at here, let's say this is A, this is B, right? So ending at here is like A plus B. And ending at here is like A plus B because I just copy. Ending at here is A plus B, I copy. Ending at here will check the previous maxes, so it's still A plus B. So everything is the same. Okay, so now I put a bunch of this and then I hit a max, right? When I hit a max, it's in range. So whatever the previous, like A plus B, whatever previous still works because you go from here, get all the way down to here. Yeah, that works, right? And then because it's just the previous range. But in addition, now you have these mins, right? So now you have this min, which means you have this range. This entire range can work with this max. right? It's basically you contain this max and this min, and you have everybody, right? Everybody. Hold. Are you double counting? Right, we have this max, and now we hit a min, and I say I get everybody A, but why you do B again? B is double counting with A, so you don't do B, you just get the latest max. You get the latest max, so we can form all this. So that's not A plus B, that's just pure A. This is just pure A, right? So here is A, this is A, min, this is still A. Now we get a max, and the max, we only care about this min, right? We don't care about this, because you hit this, you will hit this one as well. So we have this thing will be what this max will add, and everybody will be, this is actually even simpler. Okay, let's code it. This might actually work. And implementation wise, I don't see this one too difficult, right? So here is my thought process. 2, 4, 4, 4, right? As we traverse nums, anytime a value outside the range is encountered, we have to reset, right? We have to reset. Then for a range or within, for a range or for a sliding window, okay? For a sliding window that all within range, right? If we hit a min, we want to know the most recent max position, right? Then we can, if such max exists, then we can compute all the subarrays, right? All the subarrays that includes the latest min and latest max ending at the latest min, right? Ending at the latest min. We can compute all of those, right? And all of those will be exhaustive. It will be exhaustive. So everything ending at this, right? It will be exhaustive. All right, moving on. If for the next within range value, it will form the same number, right, of subarrays as the most recent encounter of min or max. Encounter min, because we're talking about the min. The situation for max is the same, except we will look for the latest. We'll look for the latest min. I don't know. Does that make any sense? Anyway, so we can do this, right? We can do this. All we need to do is we have a low and we have a high. So we set low to 0, and we also need a long rest. Okay, and I say for int high equal to 0, high smaller than nums.size and a high plus. Okay, and then what we want to know is the previous int pre-min, and pre-max. Okay, and then we say if nums high is smaller than min k, or nums high is larger than max k, so this is out of the range, then what we do, we will do low equal to high plus 1. That's a reset, right? And then pre-min equal to pre-max equal to -1. I believe this is legal. Yeah, I think I just read it. This is legal. Actually, this is not legal. Shoot. Okay, but this is legal. This is not legal, but this is legal. Okay. Yeah, this is a reset. So I can say this is a reset. Else, right? Else, now we're in range, but there are two scenarios. So else if nums high is equal to min k, right? So we're saying we hit a min k. Now we need to check the previous max. Oh, we have one more thing. Pre-min, pre-max, and previous count, right? So I have to do previous count equal to 0. So if that's the case, right? So now is min. So we need to find the previous max, or that's not really previous max, the latest max. That's fine. We know what it means, right? So we want to find the previous max if it exists, right? So we say if previous max is larger or equal to 0, which means we have a previous max. So in that case, right, we have a previous max. That is the number. So what we want is, let's say previous max 0, 1, 2 is 2, right? Previous max is 2, and the total number that contains the current range will be, you know, this one, and this one. So it'll be 3. So it'll be pre-max plus 1. Okay, pre-max plus 1. That is the total number, pre-max plus 1. So we'll set the pre-count will be equal to pre-max plus 1. Right, that's the new pre-count. And this can all be, yeah, this can all be int. Right, that's the pre-count. We updated the pre-count, right? So that's if pre-max is larger than or equal to 0, then we updated the pre-count. And once we update the pre-count, if pre-max larger than 0, if not, then we don't do anything about the pre-count. But whatever, we all say pre-min will equal to high, because I encountered that's the new min, right? So else, we say if pre-min is larger or equal to 0, then pre-count will equal to pre-min plus 1, right? And then pre-max equal to high. All right, so once all of this is done, then we can say res equal to res plus equal to long pre-count, right? We add the pre-count to it, and that's it. Right, that's it. So if it's outside the range, pre-count will be 0, so we add it to it, it's fine. If it's inside the range but not equal to min k, min max k, right? So if it's not either, then we will just reuse the previous count, right? And if it's equal to one of them, then we check, right? We check and then we update. Check and we update. We update the pre-count. So we've done that, and we can return the result. All right, we'll use these simple cases to try. Oh, the second one is not right. The first one is, dude. I believe we have to do pre-count. Huh. That's actually not true. Let me think. So, 1, right? Yes, it's min k. Ooh, min k. But it's both a min k and a max k. Huh. Huh. Min and max are the same. Seems like we cannot use this method. Min and max is the same. If it's equal to min k, I'll set the pre-min. But this time I don't have a pre-max. And then if it's equal to pre-max, then the pre-min has already been set. Then pre-count is the pre-min plus 1, so I have 1. All right, and then pre-max equal to this. And next pre-min, I will do whatever. Right, it's a min, and I will count. Ugh. Because it can serve as min or max. So if it's a min, I will look back, and then it's also a max, and I'll look back as well. So we counted twice, but at the end we can just divide by 2, right? So okay, so the solution is, if this, then we just continue. Okay, continue. And then this will do a separate one. So if it's this, I do this. If it's this, I do this. Then we'll plus equal to the yeah, it doesn't matter, right? It doesn't matter. If it's min and max is different, then we only do it once. If min and max is the same, then we'll do it. Still, we do the count only once. All right, let's try it. Just slight shift. Yep, a slight shift seems to work. Let's try. Shouldn't we reset? Oh, shoot. I know why. We need to record the... Oh, dude. We need to record the... Damn. Low. We need a low. Because reset is... Yeah. Blah, 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 blah. This is a pre... max. This one need to minus low. I forgot. That was my bad. I need to say this minus low plus 1, so that's the total count. Okay. Yeah, so this has to be minus low. And let's use this test case. That shall do. Yep. Okay, try it again. Yes. I think this one is easier than yesterday. I mean, it's also because I'm doing it pretty early today, and then I can feel the difference in my thought process. Like, this thought process is pretty straightforward. Like, I didn't feel any lagging, right? Any specific lagging, but this is pretty good. I think last time I probably solved it myself as well. Yeah, and without even having to. Oh, dude, this is terrible. But yeah, I did myself. And then that's Java, and then I think this is the official solution. Most recent. And then reset. I like how I think this is exactly how we're supposed to do it. I think this is the second time I do this problem. Yes, I think we follow the same procedure, which is good. And let's see, 2023, 2024, and 2025. And this is the official solution. Yeah, we reset if it's this, if it's this, if it's this, and then we will do this. If it's this, I'll set. So I think what it's trying to say is I don't need to do this, right? If it's this, I should do this. If it's this, I should do this. And I will set the pre-count shall equal to, because I have a pre-min set, but that depends on if I'm a min or I'm a max, right? Oh, we can pick the minimum. We can pick the minimum. Yeah, we find the pre-min and pre-max. We find the minimum, because if one of them is not available, the minimum will be smaller than 0, right? So we say if minimum of these is larger equal to 0, then we will just do, we'll find the pre-count, which is the maximum, right? The maximum, the maximum will be yourself though, right? Because I myself right now is either a min or max, and I need to find the opposite, right? I need to find the opposite. So it is the minimum, right? It is the minimum, because you update the current one, which is going to be the max, so it is the minimum. So we'll do current minus the minimum and plus 1. So here is a slightly improvement. So I say I will do, if this, I'll do this, okay? If this, I'll do this, okay? And we say int minimum pre-position. index shall equal to minimum, pre-min, and pre-max. Okay. Then we say if minimum pre-index is large or equal to 0, then res plus equal to the current, no, that's the minimum pre-index minus low plus 1. Minimum pre-index. So I don't even need a pre-count, but I do need minimum minimum pre-index. Minimum pre-index. Smallest index, lowest index, leftmost index. Okay, leftmost index. So leftmost index is equal to this. If leftmost index is larger equal to 0, then we'll do leftmost index minus low and plus 1. And the next one will do the same. Next one will do the same. Let's try this to see. Yeah, we don't have this. We have leftmost index. That doesn't matter, so I don't really need to set this value actually, because leftmost index will every time we'll recompute it. Right, so this is same as the previous solution, but slightly better implementation. I call it slightly better implementation. I'm not 100% sure if this will work. Okay, so far so good. Let's see if it will work. Yep, it does. Right, it does. It's pretty good. I don't know why it's slower. I mean, code-wise, it's actually easier, right? It's actually easier. I mean, maybe it does one more comparison. No, we have 1, 2, 3, 4, 5 comparisons right here. 1, 2, 3, 4 comparisons. I do not know why. Maybe because I have to do this multiple times. Maybe because I have to do this, but it doesn't matter. We solved this. Okay, that'll be it for today. I will